Are you familiar with the measures of central tendencies? Do you still remember the measures of central tendencies? What are they? What can you say about their differences? Measures of central tendencies of ungrouped data? Let's learn about it today. Good day, Sir Jess here. Be prepared as we broaden the scope of our perspectives on the real-world applications of mathematics in the local settings. In this adventure, you will need a pen, paper, and an active mind to empower with fresh math ideas. Before we start with our lesson, let us first have a simple activity. This activity is titled Interactive Claw Machine, Rebus Puzzle Edition. So what you need to do is to guess the rebus puzzle within the gift boxes that will be picked by the claw in the machine. Okay, so let's start. What is your guess? The correct answer is 4 ones in my life, since there are 4 ones inside the word my life. Let's try another one. What is your answer? The correct answer is forget it, because there are 4 get its. Okay, so let us try another one. What do you think is the answer? The correct answer is mood, simply because it sounds like mood or pertaining to the emotions. How about this one? The correct answer is mean. Mean girls minus girls is equal to mean. Let's try another one. What do you think is the answer? The correct answer is median. Mid plus ian is median, which sounds like median. Okay, so that's it. Let us read our learning outcomes. At the end of the lesson, I can differentiate the 3 common measures of central tendencies. I can solve for the measures of central tendency of ungrouped data. And I can recognize the practical application of measures of central tendency in the real-world settings. Let us first define some common terms. A measure of central tendency is a descriptive statistic that describes the average, typical value of a set of scores. We have 3 common measures of central tendencies, such as the mode, the median, and the mean. The mode is the value that occurs most often in a data set. A dataset that has only one value that occurs with the greatest frequency is said to be unimodal. So as we can see in our graph or distribution in the screen, this is an example of a unimodal distribution since we only have one mode. When a dataset has 2 values with the same greatest frequency, both values are considered as the modes. The dataset is bimodal. So, the example of distribution on our screen is a bimodal distribution since we have 2 modes. If a dataset has more than 2 values with the same greatest frequency, each value is used as the mode. The dataset is considered multimodal. What we can see in our screen is an example of a multimodal distribution since we have more than 2 values for our mode. Now, when do we use mode? The mode actually is not a very useful measure of central tendency because it is insensitive to large changes in a dataset. That is, when we have 2 datasets that are very different from each other, we can have the same mode. Let us say we compare the grades of students in mathematics with the dataset of grades of students in science. So we can have the same mode despite having a different datasets. The mode is primarily used with nominally scaled data. It is the only measure of central tendency that is appropriate for nominally scaled data. Now, the median. The median is simply another name for the 50th percentile. It is the score in the middle. Half of the scores are larger than the median and half of the scores are smaller than the median. How to calculate the median? Conceptually, it is easy to calculate the median. First, we have to sort the data from highest to lowest, and then find the score in the middle. That is the quantity of n plus 1 all over 2. If n, the number of scores, is even, the median is the average of the middle two scores. For example, what is the median of the following scores? 10, 8, 14, 15, 7, 3, 3, 8, 12, 10, and 9. First, we have to sort the scores from highest to lowest, starting from 15 and down to 3. Then, we determine the middle score. The middle score is equal to the quantity of n plus 1 all over 2. That is 11 plus 1 over 2. 12 divided by 2 is equal to 6. Therefore, our middle score is the 6th in our data. So we have to count the 6th score from 15. And that is our median, which is equal to 9. Let us try another example. What is the median of the following scores? 24, 18, 19, 42, 16, and 12. First, we have to sort the scores from highest to lowest. That is from 42 down to 12. And then, determine the middle score. That is equal to n plus 1 over 2, which is equal to 6 plus 1 over 2. 7 divided by 2 is 3 and 5 tenths. This means that our median is somewhere between the third and the fourth score. So therefore, we can calculate our median as the average of the third and fourth scores. That is 19 plus 18 divided by 2, which is equal to 18.5. Therefore, our median in this dataset is 18.5. Now, when do we use median? Median is often used when the distribution of scores is either positively skewed or negatively skewed. This means that the few really large scores are positively skewed or really small scores, negatively skewed, will not overly influence the median. So as we can see in our graph, in our screen, we can see that the tail of the upper graph is on the right side. Therefore, if we can think of the number line, this is leaning to the direction of the positive numbers, right? This could be a way for us to determine that this is positively skewed. On the other hand, the graph below shows that the tail of the distribution goes to the side of the negatives. So therefore, we can say that this is negatively skewed. This is just a way on how we can easily remember the positively skewed and negatively skewed graphs or distribution. So let us now talk about the mean. So the mean is basically the arithmetic average of all the scores. This is calculated as the summation of the grades or the data divided by the number of data, or the summation of x over n. The mean of a population is represented by the Greek letter mu, while the mean of a sample is represented by x bar. Now, how do we calculate the mean? Let us try this simple dataset: 1, 5, 4, 3, and 2. First, we have to get the sum of the scores or the summation of x. 1 plus 5 plus 4 plus 3 plus 2, that is equal to 15. Next, we have to divide the sum. The summation of x is equal to 15 by the number of scores. N is equal to 5 since we have 5 data in our data sets. So 15 divided by 5 is equal to 3. Therefore, our mean is equal to 3. Now, when do we use mean? You should use mean when the data are interval or ratio scaled. So many people will use the mean with ordinally scaled data too. And most importantly, the data are not skewed. The mean is widely preferred because it is sensitive to every score. Meaning to say, if you change one score in the dataset, the mean will change. So let's say we have the dataset of the level of satisfaction of students on the face-to-face mode of delivery of instruction. So if we change even a single rating of level of satisfaction on that data, the mean of the entire dataset will eventually change. Now, how do these measures of central tendencies relate to each other? In symmetrical distributions, the mean and median are equal. So for normal distributions, mean is equal to median, which is also equal to mode. So in this particular example or situation, we can see that the graph is a perfect bell curve. While in positively skewed distribution, the mean is greater than the median. On the other hand, in negatively skewed distributions, the mean is smaller than the median. Let's practice. I have here an example of dataset sourced from the National Nutrition Council of Mimaropa Regional Office. So let us now apply what you have learned in analyzing the measures of central tendency of ungrouped data. Our dataset shows the nutritional status or population of overweight of male preschoolers in 2020. So you can see the table here is stated are the city or municipality and the corresponding number of overweight individuals on the right column. So you will get the mean, median, and mode of this dataset. I will give you 5 minutes to accomplish this. Let us try another exercise. This dataset shows the total population and the number of barangays in Oriental Mindoro. So, we will be getting our measures of central tendencies, the mean, median, and mode for the two datasets. Get the measures of central tendencies for column 2 and 3. I will be giving you 10 minutes to accomplish this. To sum up what you have learned in our discussion, answer the following questions. What are the three measures of central tendency? How do we use each of the measure of central tendency? Take two. To sum up what you have learned in our discussion, answer the following questions. What are the three measures of central tendency? When do we use each of the measure of central tendency? How do we solve for the measures of central tendency of ungrouped data? And what do you think is the importance of the measures of central tendency in data analysis? For your quiz, get the measures of central tendency, mean, median, and mode for the following datasets. Dataset 1, 15, 18, 16, 14, 15, 15, 12, 17, 90, and 95. Dataset 2, 65, 55, 89, 56, 35, 14, 56, 55, 87, 45, and 92. For the mode, determine if the distribution is unimodal, bimodal, or multimodal. You have 10 minutes to answer this quiz. Now, for your assignment, this is titled Survey, Solve, Analyze. Think of a topic that interests you. Construct 5 survey questions based on the chosen topic and conduct a data gathering procedure. Tabulate the resulting data set of 20 responses. Then, solve for the measures of central tendency and indicate your analysis. And that's it for our lesson today. I am hoping that you have learned a lot in our discussion. If you have suggestions and recommendations, please leave a comment below. Like and share this video and subscribe to our channel so we can reach more learners. Keep learning and enjoy your day.